Good morning, all of you. Today, we are going to see power system operation control. Among these subject, we are going to see Unit 1 preliminaries on power system operation control. So, in this unit, we are going to see power scenario in Indian grid, national and regional load dispatcher centers in India, requirements of good power system, necessity of voltage and frequency regulation, real power versus frequency, and reactive power versus voltage load, system load variations, load curve, and basic concepts of load dispatching, load forecasting, then basics of speed governing mechanism and modeling, speed load characteristics of governing mechanism, regulation of two generators in parallel. So, in first topic, we are going to see power scenario in Indian grid. India is the world's third largest producer and the third largest consumer of electricity we know because population growth. The national electric grid is India has installed capacity of 370.106 gigawatts as of 31st March 2020. Renewable power plant, which is also include large hydroelectric power plants, constitute of 35.86% of India's total installed capacity. During the 1819 year, the gross electricity generated by the utilities in India was 1372 tegawatts hour and the total electricity generation. India's electricity sector is dominated by the fossil fuels like coal, then atomic power plant, which during 1890 year produced about three quarters of country's electricity. The government is making effort to increase the investment in renewable energy sources for last 10 years, and the government's national electricity plan is 2018 states that country does not need more than renewable energy sources plants in the utilities sector until 2027. The commissioning of 5,025 megawatts coal-based power plants under the construction in addition to 27,000 megawatts total renewable energy power capacity after the retirement of nearly 48,000 megawatts of old coal-fired plants. National and regional dispatch centers in India, we have 5 regional dispatch centers in India. Power System Operation Corporation Limited, that means POSOCO, is wholly owned by the Government of India enterprise under the Ministry of Power. So that the Power Grid Corporation of India Limited (BGCIL) was formed in 2009, handling the power management and the functions of PGCI. It is responsible to ensure the integrated operation of grid in a reliable, efficient, and secure manner, which consists of 5 regional dispatch center and a national load dispatch center (NLDC). So this is the black diagram of national and regional dispatch center. The national dispatch center is head of the regional dispatch center, which was owned by the central government. So responsibility of static load dispatch center: demand estimation for operational purpose, scheduling for merit order dispatch, regulating generation, load balance, schedule for central sector, monitor the bilateral power supply agreement, maintain the frequency at constant. That means which has the limits of 49 Hz to 50.5 Hz range. Load shedding implementation, coordination with the regional load dispatch center and other constituents. So the functions of static load dispatch center: the regional dispatch center shall be apex the body of ensure the integrated operation of power system whether concerned region, which correlate the power is generated and it is given to the grid. The process is monitored by regional dispatch center for each state. So the regional dispatch center is located in New Delhi, Mumbai, Kolkata, Bangalore, and Shillong. Each have northern regional, western regional, eastern regional, southern regional, and northeastern regional. So Each regional center has group of states. So what is the need of power system control? The power system is normally operated under the steady state condition. In a steady state, it is essential to maintain the power balance. That means we have to maintain the power as per consumer requirement and generation and distribution and consumption that should be equally balanced. Then only the power system will be stable. So that we need to control the power system. This is the structure of electric power system. We are studying the transmission distribution itself. Primary consumers, that means primary transmission, secondary transmission, primary distribution, secondary distribution, which is represent the each diagram. Need for voltage regulation in a power system. That means we have to maintain the voltage as constant in this power system, because if the load is increased, the reactive power consumption, that means active power is increased. Due to that, the reactive power gets reduced. We need to maintain the voltage is constant. The reactive power should be constant. The frequency regulation, need for frequency regulation. If the real power is increased, what will reflect in the power factor means the power factor gets reduced, because all the loads are inductive loads. If the loads are increased means the power factor gets reduced, which is directly proportional to frequency. The frequency gets down due to the increase of real power. So that will reflect in the power system components, that will limit. We need to maintain the frequency as constant for smooth operation. So we can frame a loop for power, real power as well as frequency, and a reactive power versus voltage. That will shows the what is the relation between the real power as well as voltage. What's the relation between the real power versus frequency? What's the relation between the reactive power versus voltage? So this is the automatic load frequency control of power system. Here it can be classified into two types: primary ALFC, secondary ALFC. That means primary automatic load frequency control, secondary automatic load frequency control. The outside of the power plant, the frequencies maintenance is called secondary ALFC. The inside of the power generation, the frequency maintenance is called primary ALFC. So here the signal mixer is given to the integrator. Integrator integrate the signals from the signal mixers and frequency sensors. The both signals are integrated. It is given to the speed changer. Based on the input from the integrator, the speed changer will give this command to the speed governor. Based on the speed changer input, the speed governor is control the valve of the turbine. That means the speed of the generator is controlled by using the hydraulic amplifier, which is leads to the control valve on and off. Okay. Due to that, the speed is controlled in the turbine, which is connected with the generator. Okay. The speed governor hydraulic amplifier with the combination is called primary ALFC. The entire setup, that means signal mixer along with the speed control, is called secondary ALFC. Real power and frequency control. The primary ALFC, the circuit primarily control the steam valve system leading the turbine, which leads to speed sense the speed of the turbine. This is compared with the reference speed governor, whose main activity is to control the speed of the steam by closing and opening the control valve if the differential speed is low. The control speed is control the frequency. So what is the electric power system operation? The objective of electric power system operation is supply the energy to the users, then meeting the first objective, the acceptable impact upon the environment, Then meeting the first and second objective continuously with adequate security and reliability. Fourth objective is meeting the first, second and third objective with the optimum economy, that minimum cost. The integrated objectives, we can combine all the objectives. First one is the quality of service, another is the environment, third one is the security and reliability, fourth one is the economy, which will let the user as the user friendly. So you can plan as a task the operation planning, operations control, operation accounting. So operation planning consists of long-term operation planning, mid-term operation planning, short-term operation planning, and operation control. All the are combined together, which leads the operation accounting and reviewing. So operation planning, we need to plan what is the demand in future and what are the converters and circuit breakers, transformers and the maintenance. What are the things we need? And also we have to fulfill the power system demand. That means what is the consumer need for the particular day or particular week. The power system should be fulfill the consumer requirement. So these are the things we need to plan, whether it is in a hydro, thermal or wind. What are the sources we have available? What is the need? We need to plan accordingly. And operation control. The operation control means we are going to fulfill the we are going to deliver the power as per consumer requirements with control manner. What are the control parameters are there means load frequency control, online load flow, economic dispatch calculation, operating reserve calculation. So load frequency control means if the load is increased, which will reflect in the frequency, we need to maintain the frequency as constant. At the time, we need to increase the speed of the turbine, which will let the frequency as constant value. So next one is the online power load flow. So what is the exact load required at the particular time and instant? Then we need to monitor the power as in a secure manner. These are the functions is called an online power flow or online load flow. Then economic dispatch calculation, we have so much of sources. Among these sources, which one is economical compared to the hydro or nuclear? The atomic power generation is high. So which one is cost wise economical and which one is uh, easily controlled? These are the parameters we should know. Among that, we first of all choose the economical power generation and ensure that. Then operating reserve calculation means whether suddenly the load is increased, we can't able to increase the power generation at the instant time. So that we need to maintain some reserve that should be calculated. We should know how much reserve we have. This is the pictorial representation of economic dispatch, which it says the given set of units running how to load much should be generated each cover and load and losses. This is the question, major questions for economic dispatch. So deciding which units we need to commit. We have 5 or 6 number of units are there for power generation. Cost wise, which we are going to commit. So unit commitment. What is the unit commitment means? We have a number of sources. Among the n number of sources, what are the sources we have to commit for generation? That is called unit commitment, which include the startup cost, shutdown cost, spinning reserve, and then somewhat parameters. Okay, then Load on power system. The function of power system is to deliver the power to large number of consumers. A load of a power system is never constant. It is varies from time to time. Am I right? Because for each time that demand will be varied. Practical example, we are consuming the power in evening time compared to the daytime. So effects of variable load. First one is a need of additional equipment. If the load is varied, we need to fulfill the power. So as per load requirement, we need to supply the power. Additionally, it is the reserve should be maintained. Then increase in production cost. The variable load increase the production cost also because suddenly the power need means we don't have time. Suddenly we let for atomic power generation. So the compared to the cost of hydropower plant it's increased. The cost of load increase it leads in the production cost. So all of you know Michael Faraday many years efforts are rewarded when they discovered the electromagnetic induction in invented the first generator. These are the historical events we know very well in this. So types of load. The 20 in this world, 25% of load is resistive load. That means lighting equipment and heating equipment. Then 70% of load is motoring load like compressor, air, industrial, power tools, car, the electric vehicle, household applications. Then electronic devices load is 5% like TV, television, laptop, mobile phone, okay, adapters. So load curve. What is the load curve means? If we draw the graphical diagram, the time is in x-axis and the load is or demand in y-axis. That's called load curve. Load duration curve means this is a descending order of load curve is called load duration curve. Types of load: domestic load, commercial load, and industrial load. For each has different demand factor, diversity factor, and load factors. So the types of load which will continue this in this slide also. For heavy industries, the demand factor may be varied, and agriculture it leads to load factor and the diversity factor is maintained as 1.2, 1.5. This is the graphical diagram of load curve for the hours in x-axis and load in kilowatts in y-axis. For each time the load will be varied. It's a graphical approximation. So load curve can be classified into three types. One is the daily load curve, monthly load curve, and annual load curve. The daily load curve means which relates the 24 hours per day. It's a 24 hours in x-axis and y-axis. What are the demand? Monthly load curve means it's a day-wise load curve. For 30 days, first day how much load, second day how much load. That will represent. Annual load curve means it's a month-wise load curve for 12 months, which will represent. So what is the need for load curve? We can get the load variation and how much amount of power generated. We can easily identify it. What is the maximum demand of power system and average load and also load factor. Load duration curve means it is the descending order of load curve. Okay, the load arranged in descending order as per the magnitude. We can find the load factor, the number of hours during which the load is prevailed. It can be extended to include any period of time. This is the pictorial representation of load curve and load duration curve. First one is the load curve, another one is the load duration curve, which is it is arranged in descending order. So what are the information we can get it from the load curve means we can show or we can get the variation in load and the units generated per day, peak of the power, the peak of the demand, and also preparing for load schedule. That means operation schedule of station. It will be leads to used to load forecasting techniques. So the important terms and factors from the load curve we can get it: connected load, maximum demand, demand factor, and average load. Load dispatching. The supplying of load power to the consumer is called load dispatching. The loading of units are allocated to serve the objective of the minimum fuel cost. For that, we are using thermal scheduling. It can be classified into three categories: long range of hydro scheduling, which leads to interval the time of depends upon the reservoir capacities, or 1 week to 1 year or several years. So the statistical variables like load, hydraulic inflows, and unit availabilities, we can get it from the load curve data. Short time or the long term hydro scheduling, the data is maintained by the hydro power plant load curve. So from that, we can schedule the power for future. What is my load forecasting? Load forecasting is the calculation of future power demand in advance. So how it can be calculated means we have the graphical data from the load curve. From the load curve, we can find out the future demand for next somewhat years or next week, next days as per our requirements. So classification of load forecasting, it can be classified into four types. One is a very short term load forecasting, then short term load forecasting, medium term load forecasting, long term load forecasting. So what is the need of load forecasting means? To meet out the future demand, and the long-term forecasting is required to preparing the maintenance scheduling of the generator unit, planning future expansion of the system. For your day-to-day operation, short-term load forecasting is needed in order to commit the enough generating capacity for the forecasting demand and for maintaining the spinning reserve. Very short-term load forecasting are used to generation and distribution, economic operation, scheduling, and load dispatching. Medium-term load forecasting is needed for predicted monsoon acting and hydro availability and allocating of spinning reserves. So this is the speed governing system to control the frequency of the system, which includes the modeling of speed governing system, movement of C, speed governor model, movement of T, movement of E, turbine model, generator model, and conclusion. So this is the black diagram of speed governor modeling. Here, first one is the speed changer, another is the speed governor, hydraulic amplifier, then turbine. These are the important components of speed governing mechanism. So modeling, we can find out the speed governor model, turbine model, generator model. Combination of all those things is called single area system load frequency control. Here, the lower and rise. That means when the speed governor is rotated, that will change the position of the XT, and which leads the hydraulic amplifier piston moves. The valve will be open and closed, which is given to the turbine. So if the valve is gets closed, means that input to the turbine is low, the speed of the turbine gets reduced, which will reflect in the system frequency. If the frequency we got to maintain, or if the frequency is to increase means If we change the speed governor position, the valve gets open, the input to the speed governor is increased, that will leads the frequency increases. So this is the speed governing system mechanism in a power system. We'll continue. Thank you.